Hello everybody and welcome to a new open class number 137. Welcome everybody. Today we are going to be talking of navigation 2, specifically how to do mapping and specifically how to do mapping using the SLAM Toolbox package and methods that it provides. All right, so yeah, welcome everybody and let's already start. Let me know please in the chat if everything is all right, everything is working properly. If you can see me properly, you can hear to me properly. Let me have a look here at the chat to confirm that everything is fine. Okay, I can see there Jaron Lundwall says works for me. All right, so let me already now switch to my computer screen and let's start. So yeah, there we go. Then as always, same method as always. Probably you are seeing me here in this screen. So the first thing you need to do in order to start with the open class is to click on this fork and open the class project. All right. So I'm going to click here right now. Then this is going to copy the project of today's open class into your workspace, and it's going to also automatically open it, as you can see right here. Okay, then you are going to have also here in the right side all the streaming section with the live stream, the chat in case you want to type anything. Okay, you can move this to another tab if you want to have these as free space, whatever configuration you prefer, you can do it. All right, I'm going to leave it here because this way I'm going to be able to see the chat in case you have any question, any issue, whatever. I can read you quickly here. All right, then yeah, so let's wait now until the project files fully load, and this is going to be the project where we are going to be working on today. As you can see, the notebook opens here automatically, so check that the proper notebook has opened. It should be the one for the open class number 137, as you can see here in mine. So I'm going to give you a few moments until it fully loads. Then yeah, let me just summarize a little bit and set things up. So today we are going to be seeing how to perform, how to create a map, how to do mapping in ROS2. In this case, we are going to be using the SLAM Toolbox package. Okay, which is a set of tools, as the package name says, for doing SLAM, both for mapping, localization, etc. But today we are going to be focusing on the mapping process. Okay, we are not going to go too deep into that, but we are going to see some interesting things about this SLAM Toolbox package and features that it provides, and we are going to see what is the basic setup that you need to create, that you need to have in order to create a map of your environment for any robot. All right, then okay, so the first thing we are going to do here is to launch a simulation. Okay, then just down here you have the steps in how to do it. So the first thing we will do is to open a new shell, which we can do by clicking on this icon in the bottom bar. First icon, we can click here and this is going to open a web shell. There we go, which is just like a regular Linux shell where you can type commands and so on. So yeah, here then I'm going to run the following commands that I have here in the notebook. You can directly copy them from the notebook and paste them here, as you can see. This is the first one where I'm going to source the simulation to workspace, and then in the second one I'm going to run this script, which basically is going to start the simulation. Okay, you can have a look at the files, folders, and everything you have in this project by opening the IDE, which is the second icon here, which says Code Editor. So we can click here and this is going to open the code editor, which is going to give you access in a graphical way to all the different folders and files that you have and that you are going to create here into your project. All right. Hi, did you open this from public project? I don't understand what you mean, Misbah. No, okay, yeah, no. So this project, in order to open this project, you have to come here. Let me show it one more time. Here in the workshops area where you are seeing the live streaming, you have to click on this button here, this light blue button, which says fork and open the class project. Okay, in case that anybody has just arrived, okay, remember you have to click on this button here, fork and open the class project. Then this is going to automatically copy this project into your workspace and open it. All right. Okay, then after some seconds, you are going to have the simulation loaded. Then you might find a book here. So as you can see, in my case, the robot has not loaded. Okay, so this is the expected result. We should have our robot here. Okay, and in my case, there is not the robot is not there. Okay, so this sometimes happens in Gazebo, some books that are there. So in this case, we are just going to Control-C the command. Okay, press Control-C here and relaunch it. Now, yeah. So this second time you run it, this is going to probably get stuck here in Gazebo. So let me close it one more time, and now it should work properly. It should load the world with the robot in the middle. Let's see. Yeah, there we go. Okay. Yeah, so now we have the world. As you can see, it's a quite simple world with the robot right there in the middle. It's a Robotics MP400, which is running on ROS2. Okay, so this robot works with ROS2 already. All right. Then, yeah, so first thing, we have started our simulation. Okay, this is the first step. Open a new shell, run the commands that you have here, which are going to start the simulation. Okay, here I'm having some problems loading the IDE. Let me open it again. All right, there we go. Then the other thing I was commenting also is that you can open the code editor by clicking here on the second button, the second icon, and this is going to give you access in a graphical way, which is always much more user-friendly, to all the different workspaces, files that you have here. For instance, you can see here the simulation to workspace, which contains the simulation-related packages. All right. So, for instance, this is the script that we have launched. Start basic Neobotic sim sh. As you can see, this is the script that we have executed, which basically, if you go inside and check, this is just doing some sources and setting some global variables. And then it's running a ROS2 launch command to start the simulation. All right. In any case, we are going to be working here in the ROS2 workspace, okay? Inside this one, so yeah, let's leave this code editor open because it's going to be useful in order to create and edit files. Okay, yeah, so this is the initial setup. We are inside the project with the simulation launch. Here we have our simulation running and prepared here with the notebook opened. All right, so let me know if you are here in the same step. Any issues? So you have the simulation already loaded. You can see properly the robot here, the Robotics MP400. You can see the robot here in the middle of the simulation. Everything is working. Are you properly set up? I would like you to wait until you are set up in order to continue, so that we can all advance together. Because I want you already know this, but my simulation is still loading. Says simulation loaded, robot is missing. Okay, if you are having problems on this, just Control-C the command. Okay, Control-C here and run it again. Okay, Control-C the command and then you just run it again. Okay, sometimes because of a book, it doesn't load properly. Okay, so in case that you don't see the robot, there, or you have the GC client loading forever, just Control-C the command, cancel the command, and run it again. Rerunning, says Ryan. Misba says, IDE is not loading. Okay, if you are having problems with the IDE, you can try maybe closing it and open it again. Maybe hitting here in the reload button. Okay. Try these things. My sim is now working, says Jaron. Okay, great. Yeah, let me know once you have everything set up so that we can continue, okay? As I always say, I want you to be practicing with me. I don't want you to be just there listening and watching to what I am saying and what I am doing, but I want you to be practicing instead. So I'm going to be here creating some packages, some files, doing some practical tests and demonstrations that you can replicate at the same time. This is why we are sharing this project with you, so that you can replicate and test everything that we are going to do here in this open class. You can do it by yourself. Okay, Ryan simulation is working also. Great. Okay, so yeah, I think that we can start with the open class. So yeah, first of all, let's define what is a map in ROS or in ROS2. Yeah, the definition is the same. So a map is a representation of the environment where the robot is operating. Okay. So in this case, we have the robot here, which is the MP400 from Robotics, and then the environment he's in, it's all this. In this case, it's an hexagonal, right, kind of environment with some cones here at one side and at the other, a ball here in the center. So all this is the environment where our robot is. Then a map, basically it's a representation of this environment. Then we are going to use this map, of course, for navigation. Specifically, we are going to use it for a couple of things. First of all, to localize the robot in our map, and therefore to be able to localize the robot in our environment. And also we are going to use it to plan trajectories in our environment. So we are going to be able to send a navigation goal to our robot so that the robot can autonomously navigate towards this goal while avoiding obstacles and so on. All right? So in order to perform autonomous navigation, a map is very important. It's one of the most important things and elements that we need to have. So, yeah, so maps in ROS and also in ROS2 are known as are grid maps. Yeah, so yeah, basically a grid map is a map which you can understand as a series of values, and each value, also a series of nodes, let's say, and each node has a value, and depending on the value, that node or that point, let's say, is going to be either occupied or unknown space, occupied space, free space. Yeah, we are going to understand this better once we create the map. Okay, and what do we need in order to create a map? Well, we need a robot which has a LiDAR, a laser mounted on it. So it is able to get laser readings, laser measurements, and odometry. It has an odometry system, all right? And of course, well, we need a robot environment, because without a robot environment, it doesn't make much sense to create a map, all right? Then, yeah, so one of the biggest problems in navigation is what is known as SLAM, which stands for simultaneous localization and mapping. Yeah. Then there are different algorithms which have been created during the years in order to solve the SLAM problem. And also there are different ROS packages and ROS2 packages which are meant for solving this SLAM problem. For instance, a couple of examples in ROS2 are Cartographer and SLAM Toolbox. For ROS1, for instance, there is the Gmapping example. But since we are going to focus today in ROS2, let's talk about ROS2. So a couple of examples of packages that solve this SLAM problem are Cartographer or SLAM Toolbox. In this case, for this open class, we are going to be focusing on SLAM Toolbox because it's the most complete one. It has many features. It is also the better supported one. So we are going to be working with the SLAM Toolbox package, which has been developed by Steve Masensky, by the way, which is a great ROS and ROS2 developer. And you have the link to the official repository here. I'm going to open it here because we are going to be visiting this and checking different things from the official repository, okay? Of course, you have here many information related to the package in case you want to learn more, because this package provides many different features, many ways in you can optimize, configure the package, okay? We are not going to be covering everything because it's impossible, but we are going to be seeing some basic stuff today. All right? Then, all right, so the first thing we are going to do is to create a launch file for starting the mapping process. Then for this, of course, the first thing we need is to have the SLAM Toolbox package installed in our system. All right? In our case, we already have it installed. We can check it very easily here with a ROS2 package list command, for instance. And then I'm going to grep here for SLAM. And here I can see that I already have this SLAM Toolbox package installed. All right? Then, okay. Then this package provides different nodes. For even for mapping, it provides different types of nodes. Okay. In this case, for this very first and basic example, we are going to be launching the async SLAM Toolbox node. This is one of the nodes which the SLAM Toolbox package provides, and it's meant for mapping. Okay. For asynchronous online mapping. Okay, we are going to try to clarify later what this means. Then, so this async SLAM Toolbox node is provided by the package SLAM Toolbox, right? Then we are going to be starting and running this executable, this node, async SLAM Toolbox node, which requires a couple of parameters. First one is this use sim time parameter, which basically it is a boolean which indicates if this node must synchronize or not with the time of the simulation. Okay, as you can see here, we are setting it here, and then we have in this case this variable SLAM params file, which basically contains the path to the configuration file, containing all the mapping related parameters. Okay, so the structure of the node we are going to start is going to be something like this, where we indicate the parameters associated to this node. Remember that in ROS2 parameters are associated to each node. Then we indicate the package, which is a SLAM Toolbox, the node, the executable that we want to run, which is this one, async SLAM Toolbox node. We indicate a name for this node. We provide a name. And then finally an output. Okay, so all the output of this node, we want to get it into the screen, into the shell. All right. Then the final launch file would look something like this. Okay, so let's start by creating it, and then we are going to have a look into this file. So the first thing we are going to do here is to create a ROS2 package like this, very simple. ROS2 package create ROS2 mapping. Okay, so let's come here inside the ROS2 workspace src folder. Okay, ROS2 workspace src folder, and inside here I'm going to run this command in order to create my new package. There we go. Okay, so now I can see here that a new package has appeared inside my ROS2 workspace, which is named ROS2 mapping. Now, inside this package, first thing I'm going to do is to create a new folder named launch to add inside here launch files. Then in this case, I'm going to create this launch file. I'm going to name it like this: online async launch.py. All right, so let's create this new file, and now let's fill it with the following contents. All right. Then let's have a look at this launch file. This launch file basically, sorry, this launch file basically, it's the same one as the ones provided here by default. Okay, you can see here online async launch. So basically, we are creating a launch file like this one with some slight modifications. You are going to see now that we have included some things to kind of trick you and not making it so easy. Then what's going on here? All right. So first of all, we have some imports, different imports that we need for our launch file. We're importing different modules: node module, launch configuration, declare launch argument, launch description, etc. Okay. Then we have our function to generate the launch description. Then here we are defining some parameters, as you can see. Use SimTime and slam params file. We are declaring these two parameters. We are initializing the variables actually here. Then here we are actually declaring the launch argument, which is use SimTime. By default is going to be true, and here we have a brief description of this argument, and we do the same for the slam params file argument. So we declare this other launch argument with the default value. Then here we are basically indicating the path to the configuration file. The configuration file is this one: mapper params online async.yalm, which is inside the config folder, inside the slam toolbox package. Yeah. So I am indicating here the path to the parameters file, which is this one here. Again, a brief description, and then we are starting our node. Here we are assigning the proper parameters, which are slam params file and use SimTime. Then we indicate the package, the executable we want to run, we provide a name for the node, and we indicate the output. All right? And then finally, we set everything as actions, and we execute them. Okay? At the end, what we are going to do is to run this node with the following parameters. The use SimTime set to true, in this case, and the parameters indicated in this parameters file, which is inside the slam toolbox package. Okay, so at this point, what we are doing basically is to load the default parameters for this node. Yeah, we are not modifying anything. We are just getting the default parameters, which are provided by the slam toolbox package, by this file, and we are loading these default parameters. Yeah? Make sense so far? Any questions? Are you following? No? Completely lost? I'm good, says Jaron. All right. Okay, then let's try it, right? Then Maciej Morawski also says everything okay. Perfect. Then yeah, so let's try it. Then before trying it, we are going to have to include one thing here in our cmakeLists.txt file. So let me go back to the notebook one moment, and here we are going to, as indicated in the notebook, we are going to have to add these lines into the cmakeLists.txt file. So I'm going to copy them directly here from the notebook and paste them here. All right. Then basically here what I am doing is to install my launch folder and the files inside my folder into the share directory here in the install. Okay. So basically I am installing this launch folder and the files so that the ROS2 system can find them. Let's say. Then once I have added this, so I have created my launch folder with the launch file inside it. I have specified here in my CMake file to install this launch folder. So now I am ready to compile. Then let me go to the root here of my workspace, home user ROS2 workspace, and run the colcon build command in order to compile my package. There we go. All right, then let's source the workspace, and now let's run our launch file. So ROS2 launch, ROS2 mapping, and it is, what was the name? Online async launch. Okay, online async launch.py. There we go. All right, so we have our launch file running. It has started here the async slam toolbox node. Very well. So next thing, once we have our mapping node running, next thing we should do is to start RVs, right? In order to be able to visualize this mapping process and to be able to visualize the map that it's being generated. So for this, we are going to start an RVs2 node right here in another shell. Okay. So right now, as you can see, I have the simulation running here in the first shell. In the second shell, I have running the launch file that I have just created. And now I have opened another shell here for RVs2. Okay. By clicking here into the add button, you can create as many shells as you want. All right. Okay, then we have RVs running here, which this is going to automatically open here the graphical tools window, as you can see with RVs. Now here, in order to visualize the map, we should add here a map display. Yeah, in RVs, here we click on add, and then we select the map display, which we have right here. Let's add it, and now we have to configure it and set the topic here, which is map. Yeah, so the map that it's being generated by the mapping node, it's being published into a topic named map. So if we want to visualize this map, we have to subscribe to this map topic. So let's add it here, and nothing is appearing. Okay, don't worry, don't panic. This is normal. In fact, if we open here, we can see a warning message which says no map received. Okay, so something is happening here that it's preventing my node from creating the map. What can it be? Well, it can be many different things, okay? Does somebody have any guess? Is somebody brave enough to We are not generating a map yet. No, so we have tried to run our mapping node, but it's not working. Okay, as you can see, the map is not being generated. So there is some kind of problem here. Okay. Then in this case, I'm going to spoil it to you. So when things like this happen, there are many reasons which could make a mapping system not to work properly. Okay. In any case, most of the cases it's related with either topic names or frame names. Okay. From my experience, these two are the most common causes of any navigation-related problem. Okay, topic names and frame names. Then, in this case, I'm going to spoil it to you. In this case, the problem is the topic name. Okay, so Let me stop already here RVs and my mapping node. All right, so we are going to see more on this later, but by default, okay, by default, this node, the node that we are running, by default, this node, async slam toolbox node, is expecting to get the laser data. Okay, so first of all, how the map is being generated? Well, it's being generated based on laser readings, right? So the robot has a laser. This is one of the things that we set that it is required in order to be able to generate a map, if you remember. Yeah, so it needs, we need a robot equipped with a LiDAR. Yeah, so our robot, in this case, it has a LiDAR. In fact, these blue things that you can see here in the simulation represent the laser beams, all the laser beams, okay? As you can see, behind this sphere, we don't have laser beams because they are colliding here with the front of the sphere, right? Then, okay, so the node, our mapping node, basically it's going to get all these laser measurements and it's going to decide if all this is free space or it is occupied space, etc. Yep. Summarizing a lot, there are algorithms behind there, but I'm not going to go into that. Then, yeah, so one of the things, in fact, the most important thing that this node needs is to be able to subscribe and to get this data from the laser. Then, by default, this node expects to get this laser data from a topic named scan. Okay? So by default, this node expects to get this laser measurements data from a topic named scan. Now, what happens in our simulation? If we do a ROS2 topic list, we are going to see that we don't have any topic named scan, right? Instead, the laser data that our robot is generating is being published into a different topic, which is named base scan. Yeah, not scan, but base scan. So what is happening? What is happening and why we are not being able to generate the map is because our node, with the default configuration that we are loading here from Slam Toolbox, this default configuration, actually we can look at the default configuration here from the original repo. So basically here, right now we are loading from the Slam Toolbox package from the config folder. We can come inside here, Slam Toolbox package, config folder, and we are loading the mapper params online async .yarn. Yeah, so we can check this file right here. Then we can check between the different parameters, and we can see this parameter here, which is named scan topic. And you can see that by default, this parameter is set to scan. So what is happening here? My node is trying to get the laser information from a topic named scan. But my robot doesn't have this topic. So at the end, the node is not getting any laser data. Therefore, it is not able to generate a map, right? So what should we do now? How can we solve this problem? Any suggestions from you? Change the params file. Okay, very well. Jaron has a suggestion, which is to change the parameters file. Okay, let's do it. Then, instead of loading the default parameters file, which is this one, I'm going to create my own, and I'm going to load my own. All right? So, okay, let me come to my package, and I'm going to create a new folder named config. Then I'm going to create a new file also. Inside my config folder, here I'm going to create a new file, and I'm going to name it the same, mapper params online async.yalm. Okay, there we go. So now I can grab it directly from here. You have also the template in the notebook, all right? So I'm going to grab here the default parameters file, and then I'm going to say, hey, my scan topic is not scan, but instead it's base scan. Okay? So I have to update this scan topic. Yeah? In fact, I don't need all these other parameters because I can leave them to default in this case, okay? So if I want, I can remove all the parameters from here and leave only the parameter that I am changing, which is a scan topic, okay? In any case, usually you are going to leave all the parameters, even though they are left to the default value, you are going to leave them there because just in case that you want to tune them or whatever, it's easier to have them here, okay? In this case, sorry. In this case, the only parameter that I'm going to update is scan topic, and I'm going to set here the topic name where my robot is publishing this laser data, which is base scan. All right? Okay, then what else? Okay, so I have created here my parameters file, but now I need to load it, right? So now I'm going to come to my launch file and I'm going to say, hey, don't go to Slam Toolbox package, but go to my package instead, which is ROS2 mapping. So from the ROS2 mapping package, inside the config folder, right, you are going to load this parameters file. Mapper params online is async.yalm. Right? So now I am loading my parameters file, where I have changed the scan topic parameter to match my robot. Yeah? Makes sense? So, okay, then let's see. Let's try to recompile everything. Colcon build, I'm going to recompile my package so that it gets the new modifications. Let me source it, and I'm going to run it again. ROS2 launch, ROS2 mapping, online async launch.py. There we go. So let's come back. Yeah, so let's launch again ROS2 then. Let's launch it one more time. There we go. Again, let's come here and add a map display. And let's configure the topic name, which is map. Okay, so now we are actually getting our map generated. Okay? Everybody has reached this point. So have you been able to generate the map? To start generating the map and visualize it in ROS2? Yes, no? Any issues, questions so far? Okay, Jaron, Ryan also confirms that they are having their map generated. Perfect. All right, then let's keep moving. So let's keep going forward. Let me go back here to the notebook so that I can continue here. Yeah, so update everything. Oh yeah, so actually there's one more thing that we need to do here, which is to add this. I haven't done it, but I had it from previous tests, so that's why it worked for me. But otherwise it shouldn't work, okay? So we need to generate here we need to install also the config folder. The new folder that we have generated here, we need to install it, right? There we go. Yeah, so we should get something like this, right? Then at this point, we can run this command, the teleops twist keyboard in order to move using the keyboard our robot and generate a complete map. So let's do it. I'm going to run this in another shell. And then with this, I'm going to start moving. Let me put here the map in one side and the simulation in the other. There we go. Okay. And now, here, with this teleop twist keyboard, I can move the robot with the keyboard, okay? So I'm going to start moving the robot here around the simulation in order to, as you can see, as I move the robot through the simulation, the map is getting completed, okay? It's just starting to map all the areas. So let me keep moving a little bit the robot through all the simulation. I'm going to do a complete loop here to the environment. It shouldn't take too much. It's a small environment. Okay, so let's keep moving a little bit to generate the complete map. There we go. Yep, it doesn't have to be perfect, okay? So just so that we have a complete map here for testing, for being able to test now. Then let me go over there. Yeah, so in my case, only the final part is missing. As you can see, I'm going to come over here so that I properly map also this part here. And I don't leave here spaces. There we go. All right. So there we go. Okay, let me stop it here. Yeah, so I have here a complete map of the environment, right? So here you can see this is a grid map, okay? So these light gray colors, all these light gray areas, represent free space for the robot to move. Then these black areas represent occupied space. So this is space where the robot cannot go through. So they are obstacles, okay? And all these gray areas are unknown space. So we don't have data from this. So it's unknown space, okay? Why are there those small blank triangles by the far cones? The mapped areas? Yeah. So these areas here, if you get close through this area, you are going to be able to map it. Yes. So this is basically because of the laser beams, which are not properly reaching this area. Okay. But if you get manually closer to this is going to get also mapped. Okay. So yeah, these gray areas are unknown space. So we don't have information from the laser of these areas. Okay. For instance, here inside the sphere, the laser beams don't reach this area. Okay. So then it's left as gray, which is unknown space. Okay. Same happens here. Yeah. So if the laser beam don't reach this area for whatever the reason, this is going to be marked as unknown space. Okay. All right. Then. Yeah, so if we had more time, we can get closer to these areas and then got them mapped as well. But yeah, just I wanted just to create a quick map so that we don't spend too much time here. Okay, then let's keep going. Okay, so we have created our map. Very important. Don't stop the mapping node. Okay, so leave the mapping node running. Why? Well, because the next step, once we have our map generated, is to save it, right? So once we have generated our map, by moving the robot around, we are going to save it. Then in order to save it, we are going to use the map saver node from Nav2 map server package, okay? You have the exact command here, so I'm going to copy it here and run it here. ROS2 run nav2 map server map saver CLI command line, and then I provide a name here to my map. In this case, I'm going to name it my map. Okay, then this is going to generate two files in the path where I run this command. In this case here, as you can see, this has generated these two files, my map pgm and my map.yalm. Okay. Then basically the YALM file contains some metadata about my map, like the resolution, thresholds, etc. And this one is the one that contains all the information, the real information of the map, of the free space, occupied space, and so on. Yeah, so these two maps are generated. Okay. Then let's do one thing. Let's move these two files inside the config folder. Okay, so I'm going to do this right now. Move of my map pgm and my map yalm into ROS2 workspace src ROS2 mapping config. Okay, so I'm going to move these two files and place them inside my config folder so that I have them here. Okay. Also, you can run the command directly from inside this folder, and then they are going to get automatically saved here. Yeah. So the files are going to be generated in the path where you are running this command. Okay. Next step. So we have created the map, and we have saved our map. Okay, then next step is how to provide this map to other applications. So now that we have created our map, then this map is going to be used by other systems like the localization system, path planning system, etc. Okay, then I'm going to need to provide this map to other applications, to other nodes. Then how to do this? Well, for this I'm going to need the map server node again, and the Nav2 lifecycle manager. Okay. RVs is not necessary. Okay. Here it's added, but it's not necessary. But we do need the map server node and the Nav2 lifecycle manager. The Nav2 lifecycle manager is a lifecycle manager for navigation too. So in the previous open class, we were discussing and explaining about this lifecycle manager. So here you can see a practical application of the lifecycle manager into navigation too. All right. So what do we need here? Well, we are going to first start the map server. As you can see, we are going to start the map server node. We are going to need this node. And for this node, we are going to have to provide the useSymTime parameter, and we are going to have to provide also the file where we have saved our map so that it can load it. Okay. Next, we have to start also a lifecycle manager, which is going to basically allow the map server node to start. Otherwise, it's going to be blocked, and I'm not going to get the map. Okay, if you want to refresh about these lifecycle managers, go and have a look at the previous open class, okay, where this is explained. And then finally, I'm going to also automatically start here an ROS2. Okay, this is not mandatory. We are going to just add it here to the launch file so that we don't have to be starting ROS all the time here. Okay, then let me stop here ROS, and then let's combine all this into a launch file, which we are going to name like this: provide map.launch.py. So let me come to my package, and inside the launch folder, I'm going to create a new file, which I'm going to name like this: provide map.launch.py. There we go. And inside here, I'm going to paste the contents from here. Let me copy them and paste them here. Okay, as you can see, we are just what we have just seen. So we are creating here an argument where I am specifying where I have my map files. So my map.yalm file, this is the one that it's loaded, okay? Not the PGM, but the YALM file. This is the one used by the node in order to load the map. Then I have to specify the path to my map file, which is inside the config folder, inside the ROS2 mapping package. So here I am specifying the path so that the node can access the map file and the map data. Then I start my map server node, providing the path to my map file. I start here an ROS2 node, okay? And finally, I start my lifecycle node. And I set auto start to true. All right? This is going to start the map server node so that it's not blocked by the lifecycle manager. Hi, thank you. Mohamed says, hi, thank you for this amazing tutorial. Can you please explain the difference between async and sync methods? Yes, we are going to explain it in a moment, okay? All right, then we have created our launch file. Then, yeah, so let's come back again here, and let's compile our workspace one more time. Source. And now we are going to run our new launch file, which is provide map.launch.py. Okay, this is going to automatically open here ROS, as we are going to see in a moment. There we go. And then here we can now load. We can add a map display. Let's add it here. Select the map topic, which is map. And then initially the map it's not going to appear, okay? In order to properly see the map, in this case, everything is working. It's just a matter of setting the quality of service of the topic, okay? So in order to properly visualize this map topic, we need to change the QoS configuration. Specifically, we need to change the durability policy from volatile to transient local, okay? And here we see the map that we have generated. All right? Okay, then. All right, so yeah, basically summarizing, we have created our launch file in order to generate a map using SLAM Toolbox and using specifically this async, let me get it from here, this async SLAM Toolbox node in order to generate a map from the laser readings, okay? We have seen also how to create our own parameters file in order to change the configuration for mapping, okay? We have seen how to generate our own configuration file in case that we need to change some parameters. Like in our case, we needed to change the scan parameter, all right? Oops. Then we have generated our map, we have saved our map, and then we have now seen how we can provide this, how we can publish and provide this map to other applications, okay? Which is done using the map server node. All right? Okay, then let's keep moving ahead. We have a couple of things before finishing. Saving the map, providing the map to other applications, very well. Then, okay, so here we have a quick question, and which is about understanding how to configure SLAM Toolbox for different robots. So there are some things that we need to know, okay? So of course we can configure many parameters from SLAM Toolbox. If you come here to the default repository, you can have a look at all of the parameters down here in the API. Here you have all the exposed services, all the configuration parameters that you have that you can tune, many of them, okay? However, I have listed here some of the most important ones. So the first thing that we need to know is that the mapping nodes are going to subscribe to a scan topic. Okay, so if your robot doesn't provide this scan topic, you are going to need to change this value. Yeah, of course, this value you can change it from the scan topic. Now, other very important parameters are the frames. Yeah, so you're going to have to define a base frame and a node frame, because you need to have a transform between these two frames, between the odom frame and the base frame. Yes, so the mapping nodes from Slam Toolbox are going to look for this transform. So you need to have the odom frame and the base frame properly specified. By default, as you can see, we have here the default values, which are odom for the odom frame and base footprint for the base frame. In case that your robot uses different frame names, then you are going to need to change these names also. Yeah, this is another very common source of errors in navigation. Yeah, frame names. So take this into account. Yeah. If your robot doesn't use the default frame names, which are base footprint and odom, then you are going to have to update them as well. All right. And then so there are many parameters. So some interesting ones, for instance, are the max laser range parameter, which defines the maximum laser range to use. Another minimum travel distance. So what is the minimum distance that the robot has to move in order to consider new laser measurements? Or the mode parameter, which we can set to mapping or we can set to localization mode. In our case, as you can see from here, right now we have it into mapping node. Yeah, in localization mode, what we would do is to basically localize our robot inside this map. Yeah. Then, for instance, a very quick test we can do is to change this max laser range parameter. So we can change it. Let me look for this parameter here in my file. Max laser range. So currently it is 220. This is the default value. So what would happen if, for instance, I change this value to 3? I'm going to change it here to 3. Then I'm going to recompile. And I'm going to run again my mapping node. Okay? Not the map provider, but the mapping node. Here I have the mapping. So what's going to happen here? Well, let's see. I'm going to have, let me start one more time here, ROS2. What's going to happen here? Let's see. Let me add a map display. Configure it for the map topic. There we go. Okay, let me see, because I think that I have something wrong here. Okay, let me stop it. Let me see, have I changed something here? Mapping. Range 3, okay, yeah, this is right. Config launch. Okay, yeah, let's let me compile and run it again. Qualcomm build. Sorry. ROS2 launch, ROS2 mapping online async launch. Okay, there we go. Yeah, let's start ROS again. Yep, there we go. Let's add here the map display. What's saying here? Okay, so it looks like there's something wrong here with the frames. Probably something related to the simulation in my case, because I don't think I have changed nothing here. Although map base footprint. Yeah, no, all this is okay. Okay, so let me restart the simulation. Probably something related to the simulation. So let me restart it very quickly. There we go. All right. And let's run again the mapping node and the ROS node. All right. There we go. Let me add the map display. Okay, so there we go. Yeah, so what's happening here? So my map is much different than the one I started getting before. Yeah, remember the first map that we got was looking something like, we have an image here, something like this, right? So now I am getting this just by changing here the max laser range parameter. By default it was 20, now I have changed it to 3. So can somebody tell me what's happening? Why I am getting now this map here? Does somebody know? Or has a guess? Yes, no? Nobody? All right, so what is... Okay, so Ricardo has the answer. He says, because the laser can detect the obstacle now. Jaron is saying, I don't get why it's rectangle. Very good question. So why it is rectangle? Okay, so what's happening here is that we have set the maximum laser range to 3 meters. Okay, therefore, what does this mean? This means that all the laser measurements which are further away than 3 meters are not considered. Okay, so only the laser measurements which are within a range of 3 meters are going to be considered. Then the only ranges, the only laser measurements which have some detections within 3 meters are the ones in the front, because they are detecting this sphere here. And then this is the only information I have from the lasers. All the others, all these other beams are not getting any obstacle, so we cannot create any map from this. Oh, got it. Yes, yes. So Nima is saying there is only a laser measurement for 3 meters. Exactly. Yeah. So all the other laser measurements don't have any detection within a range of 3 meters. So I don't get any information from them. The only ones which are providing me information are the ones in the front, because they are detecting this sphere in the front. So that's why I get this, only this, right? Then what happens? But what happens if I now change it again to 20? So now the range is 20 meters again. So now all the other laser beams, all these laser beams here from the sides, right? Now I am detecting all these walls, so they are colliding with all these walls because these walls are within a range of 20 meters. Then I have much more information, so that's why I can build a better map, right? So if we change it back to 20 now, we are going to recompile here. Yeah, let's close here, recompile. Source. And we are going to run it again here. So now Let's update here the map. There we go, okay? So now I get much better information. Yeah, does this make sense? Do you understand what's going on here? Yes, is it clear now? I got it, says Jaron. Okay, great. All right, so as you can see, I have added just here into the notebook, I have just added a couple of parameters, some parameters that you can play with. Okay, you can try different values and so on, but there are many parameters that you can modify here in order to optimize many different things. Okay, so yeah, go ahead, have a look if you are interested in and see, because there are many parameters, and it allows for a lot of configuration, for different configurations. All right. Then let's go for this. So I'm going to answer right now to the question that Mohammed said. So Slam Toolbox, if we come here to the official repository and we open the launch file, we are going to see that we have different launch files, right? We have this localization launch, which is for localization mode, but we have many different launch files for mapping also. So we have this lifelong launch, these merge maps, we have the offline launch, online async, online sync, which was specifically the question that Mohammed was saying. So what are all these mapping modes? So let's try to summarize in simple words, okay, and give a simple explanation of what this is. There is much more behind all this. In fact, I have linked here a paper, okay, which talks about this, very interesting. So you can have a look, especially it talks about the difference between the synchronous and asynchronous modes, okay? So, so yeah, go ahead and check it for a much more detailed and professional explanation. But in simple words, let's say that the offline mapping, the offline mode, is to create a map without real-time data, okay? For instance, you are not going to be creating the map with the real-time data from the laser of the robot, but you are going to create it with, for instance, a back file. Yeah, so you can record the data from the laser, and then later you can replay this data as a back file, and this would be an offline mapping section. Yeah, so without getting the data live from the robot. Then the rest are online methods, which are the one that we have just done. Yeah, so the online mapping methods are the ones that are getting the laser, the data live from the laser measurements, okay? Then from here we have, we can differentiate between synchronous and asynchronous, okay? Asynchronous is the one that we have just used, yeah? And it's the most common one, okay? Asynchronous method, basically, it's going to process the incoming laser measurements in real time. So it's going to be processing the latest, let's say, laser measurement that it comes every time. Yeah. Then, for instance, what can happen? This can happen that if, for whatever reason, one of the measurements, so for each incoming laser measurement, we are going to process it. All right, in order to convert into map information. Then if one of these process goes too slow, for instance, it might happen that we lose some messages in between. Yeah? Because if we process one laser measurement, and then we get we move the robot, let's say, 1 meter forward, and then at that point, we process the next laser measurement, but we are going to process the last one. So it might happen that in between, we have lost some messages. Okay, I don't know if I have explained this very well. I don't think so. So does it make sense? So we are going to be processing, let's say, the last the last laser measurement that we receive, okay? Then it might happen that between one measurement and the next one, there are some other measurements in between that are discarded. Okay, it might happen. Okay, for simple systems, for system environments, this is not going to happen. But for systems which are more complex and whatever, this can happen. Okay, then because of this, we have the synchronous mode. The synchronous mode is going to make sure that it processes all the incoming laser measurements. Yeah, so it's not going to discard any measurement. It's going to process every single measurement, every single bayonet measurement from the laser. Okay, so it's going one, and then it's going to process the next one. It's going to create a buffer so that any message gets lost, and then it's going to start processing one after another. Okay, what can happen in these systems? For instance, for very large maps, this can lag over time because you can have a buffer too big, and because you are not going to discard any message, you are going to process all of them, you can have a lag between the map being generated and the actual robot. Yeah? Does this make sense? Do you see the difference between the synchronous and synchronous? More or less, in general terms. Okay, there are many more technical things inside there, but I don't want to get into that. Okay, then, yes, very well explained. Okay, thank you, Mohammed. Thank you. So then, finally, we have this lifelong mapping, which is also very interesting, and basically also making it very simple. This lifelong mapping basically means that you have the possibility to build a map and update it over time. Yeah, so you can create a first version of a map and save the current version, even if it's not finished, okay? Then the next day you can come and continue building the environment. For instance, for very large environments, this can be useful, yeah? So you can be building the map in different days, yeah? So basically, this is the idea of the lifelong mapping, is to be able to create a map and be able to update it or improve it over time. All right? Then I have created here a very simple demo, which I'm going to do very quickly, okay, because we are already over time. So let's see a very quick and simple demo of lifelong mapping. Okay, then let's create a new line file, which is this one. I'm going to copy it directly from here and create it. I'm going to name it lifelong-launch.py. So let me create this new launch file, lifelong-launch.py. Okay, and also I'm going to create a new parameters file here, which I'm going to name mapper params lifelong.yalm. Okay, let me create it. Mapper params lifelong.yalm. There we go. And I paste these parameters, okay? You're going to see here that it has some specific parameters for lifelong mapping, okay? Then in the lifelong launch file, I am loading this parameters file that I have just created here from the ROS2 mapping, okay? So I am loading my configuration file, yeah, from the ROS2 mapping package. And as you can see, I am using here a different node. Yeah, in this case, it's lifelong/toolbox node. Yeah, it's a different node. Then, all right, so let me save this and recompile. Okay, so actually, yeah, let me stop everything. Yeah, so actually I'm going to restart everything, even the simulation. Let me restart the simulation as well, so that I make sure that I start from the starting point. Okay, I think it's, yeah, sometimes GC client gets stuck there, as you can see. It takes a lot of time to open, so just Control-C and relaunch it. and it should load properly. All right, there we have it. Okay, then let me recompile. And then I'm going to run my new launch file, ROS2 launch, ROS2 mapping, lifelong launch.py. Okay, let's go. Then let me open an RV session. All right, there we go. And let me add again a map frame so that I can visualize the map that it's being generated. There we go. All right, so here we have the map being generated. Yeah, as you can see, I have updated here the scan topic, so here it's already right. Yeah, it's correct. So that this is working just by running it. Okay. Then what I'm going to do now is to generate half map only. Okay. So let me run here. Let me run here the teleop twist node. All right. Let me move this here to the side. And I'm going to move a little bit the robot, and I'm going to generate just a part of the map, okay? Not the full map, but just a part of the map. So let me move it a little bit, like this, very quickly, okay? I'm not going to generate a good map. So just, I want to go very quickly. Yeah, there we go. Okay. Let me come here. All right, let's stop there. Okay, so I have one part of the map generated, but there is still some part here missing, right? But let's say that I am already tired, I don't want to keep building the map, okay? I'm done for today. So what I'm going to do, okay, let me stop the teleop node. So now what I'm going to do is I'm going to serialize the current map data, what is known as serialize, okay? Then you have the command here in the notebook on how to do this, okay? Let me copy the command right here from the notebook and paste it here, yeah? So we are here calling a service provided by Slam Toolbox, which is serialize map, okay? Then this is going to serialize the current data of my mapping session into a couple of files. We are going to see it. And we have to provide here in the request call, we have to provide a name. In my case, I'm going to name it half map. Okay, so let me perform this service call. There we go. Now, if we come here and we stop our node, the lifelong mapping node, okay, we can see that the session has been saved here. See, finished serializing mapper. Now, if I check here, I'm going to see I have two new files, halfmap.data and halfmap.postgraph. Okay, these two files, let's say, that contain the serialized data of my mapping session. Okay, so what happens now? What happens now is that I can, let's imagine that I have already slept, okay, and I'm in the next day, we are in tomorrow, and then I want to continue my mapping section, okay? So I'm going to stop everything from here, let me stop everything, even the simulation, I'm going to stop it and relaunch it, okay? There we go. So now I can come here and update a couple of parameters which are here commented, as you can see, which are map file name. Here we can provide the file name of our serialized data, which is half map, right? So let me update here this name to half map. And in this case, we can specify a starting pose for continue the mapping, or to start in the dock place, which is the initial pose, yeah, the first node, which is the starting position. So I am going to start my mapping from the dock position, and I have specified my file name, which is half map. Okay, so now having set these two parameters, I can run again my lifelong launch file, and what's going to happen? Let me already start here ROS2. Let me add here a map display. There we go. With map. Well, I don't have it yet because I have not started the node. So let me start the node right now. So I'm going to start the mapping node one more time. And now, if I select the map topic, I am not getting the data from the previous one for some reason. Okay. Oh, of course, I am not getting it because I have not compiled it. Okay, so I have updated here the parameters file, but I have not compiled it, so I need to compile, right? To get the latest changes here of the parameters. Yeah, so let's compile, source, there we go. So let me run it now with updated parameters. And voila, what happens? That I am starting my mapping session from where I have finished the previous one. See? So now I can, what is this? RVs, okay. Yeah, so now I can keep moving my robot and finishing the mapping session. Right? Okay, so now I'm going to go and map the back part, the rear part. Yeah? You can continue now and complete the map. All right? So this is a simple, very, very simple example of what this lifelong mapping is. Okay? And one of its utilities. All right? Yeah? Does it make sense so far? Have you understood this last example? Yes? No? Okay, this is the last thing, okay? So we are going to leave it already here. Oops. Yes, says message. Also Nima. Excellent, excellent. Okay, so yeah, that's all. As I have been saying, Slam Toolbox provides many interesting things. Here in this open class, we have just scratched the surface. So yeah, in case you want to learn more, you have many sources here in the repo. You can learn a lot more of how this works and try it by yourself, because it's a super impressive work by Steve Masensky. So yeah, also I wanted to take just 1 minute to let you know that we are going to have a navigation to online training, okay, in the following weeks. I have here at the end of the notebook, you can click on this link, which is going to take you to the page, and here you are going to learn everything ROS2 navigation related, including mapping, including localization, path planning, obstacle avoidance, etc. Okay, so it's a super intensive and super complete ROS2 navigation training, which is going to be done very soon. So have a look in case you are interested, because it's super interesting. All right, so you have the link here at the end of the notebook. Jaron is asking, what did you change in the config YAML file to make it do lifelong? What did you change in the config YAML file? Yeah, so first of all, I have added some lifelong parameters here. Okay, these ones here. And then in the second part, which is the part that I suppose you are asking for, is these two parameters, map file name and map start a doc. Okay, so you have to provide the name of the file that you have generated, and you have to provide a starting pose, which can be the docking pose, which is the starting pose, or you can provide also another starting pose if you want to, by setting this parameter. Yeah, well, so we have created a different node here, Jaron. We have created a different node. So we are running now this lifelong slam toolbox node. Okay, we are not running the async. We have created a different launch file here. Okay, I went super quick here at the end because we are 30 minutes already. We are surpassing the time by 30 minutes, but you have everything here. Okay, so you have here the new launch file that we created, which is running this node, lifelong slam toolbox node, and you have here the parameters file also in the notebook. Okay, I just went super fast here just to show you the demonstration, but you can check all these now. So you are going to get this project forever. Okay, you can access it tomorrow, next week, to check it, and so this you are going to have it forever, so you can check it whenever you want. Okay, but yeah, here I am starting a different node, and I am loading a different parameters, which basically it's very much the same, but we are just adding some extra parameters here. Okay, so yeah, let me leave it already here. Thanks to all of you for being this 1 hour and a half. Today it's been a little bit longer than usual, but I think it was worth it. We were doing some interesting things. So yeah, thanks to all of you for being here with me. I hope you have enjoyed this open class, and I hope that you have learned something. This is the most important. And yeah, I'm going to see you next Tuesday with the next open class. And as always, until then, keep pushing your ROS learning. Bye-bye.